it's negative 5 over 13, and theta is in quadrant 3. So what does that look like? Let's just draw a really quick picture of a unit circle. And we're looking for quadrant 3, signs the y coordinate. So maybe just around right here, somewhere it's in quadrant 3. And in quadrant 3, what we're looking for is what we have is that cosine's negative and sine's negative. That's going to be important. So here's theta right here, and we have the y coordinate, which is sine, is negative 5 over 13. Now, what I'm going to use is this identity to solve this problem, which I didn't say out loud. The question is, what is cosine 2 theta? There is an identity which is cosine 2 theta is equal to cosine squared theta minus sine squared theta. Actually, I was saying that we would need to find, I was thinking we had to find cosine theta, which would work here. See, I need to find cosine theta, but instead I can do it a little bit indirectly here, where I notice that cosine squared theta plus sine squared theta is equal to 1. And I can write that then cosine squared theta is equal to 1 minus sine squared theta. And in fact, this is one form of the identity for cosine 2 theta. This is another way you see it written. So in fact, I didn't really need to notice that theta is in quadrant 2. I didn't need that little information here for this problem. So it didn't hurt that I drew that, but maybe adding too much is not good, but still. Okay, sine theta is negative 5 over 13. We square that. So we'll get 1 minus a negative squared makes a positive. That makes 25 in the numerator. In the denominator, that makes 169. And then I'll get a common denominator of 169. And that'll be minus 50 over 169. And it's up to me to get this wrong by not being able to do this in my head, or not being able to subtract. So isn't that 119? So, okay, so I was thinking that I would want to find cosine theta, which I can do using cosine squared theta plus sine squared theta equals 1. From there, I can find what cosine theta is equal to. But I'd have to know the quadrant. But actually, if I change change this identity a little. So I got it that way. Okay, so that finishes it.